morning, everyone. Happy Friday, and welcome to another episode of Mavens of Manufacturing. I have Lisa Rizzo here. I love your last name simply for the movie of Grease, just to let you know on that. Just really excited about that. Lisa, you are from HZO Incorporated, and can you just provide a little background information about what HZO is and what you do as you're the director of product management, what your role is there at the company, some of your responsibilities?
Sure, great. Good afternoon, everybody, and thank you for joining us and spending time with us all and listening about what I do in HCO. So I really appreciate the time out. But HCO we're a company that delivers thin film nano coating solutions for electronic products. We really safeguard electronics, electrical products, any product, in what we call an ever-changing world. So what we do is we provide coating that protects electronic devices. In particular, our main focus is printed circuit board. But we provide a coating that can range from nanometers thick all the way up to 40 microns, but still really, really thin coatings. And we work with a lot of the most respected brands in the market for electronics, automotive, industrial, and medical applications, provide corrosion protection from everything, including moisture to sweat, chemicals or gases, and other contaminants. And again, our main focus is in the an array of different items and coating. And our company was founded in 2011 in Utah. And that company was formed because they recognized there was a really big market opportunity to safeguard electronics from all these gross gases. And then within a couple years after, starting in 2011, we moved to Morrisville, North Carolina, where our global headquarters is, and that's where I'm located. And I hate to rub it into everybody, it's about 73 people.
That's awesome. The Midwest, we just had weather last week that was like 50s, 60s, and I think today it's closer to the 70s. So I'm pretty excited for this weekend and finally getting out and doing yard work this weekend, because we never know, like from January to sometimes May, we never know when we're going to get hit with snow or freezing cold temperatures.
We make a lot of jokes in North Carolina that you can get 4 seasons in a day, too, though. So you can get the gauntlet, but we never get the snow quite as bad as what you guys get. Although a lot of things do shut down at the dust now.
Yeah, we were kind of laughing at Texas this past year. Like it was terrible, the things that happened, because there was a lot of people without power and water for a couple weeks or so, and I had friends that live there, and like they were struggling because their power shut down, their water shut down, and it all happened just because of a simple ice storm. We think it's simple because we have the infrastructure, but there it's like the world is ending. So Lisa, with so it's CVD, right? And what does that stand for? Chemical
vapor deposition.
Okay, and then how long has that been around? So
chemical vapor deposition has been around for hundreds of years. Chemical vapor deposition, though, with Parylene, which I'll talk a little bit more about, which is what we use to coat electronics, became pretty prevalent in the 50s, and then it evolved over time and very commonly used as a corrosive coating on everything from medical devices like needles and stents all the way up to aerospace and defense electronics and circuit boards for electronic industrial applications. So it's been around for a while.
And so for like today, and one of the examples that I used for the intro video to get people to come to the live show, it would be on the circuit boards or the components in a cell phone. So just in case if you like drop your phone in water, it should help protect those components and not completely fry your phone. Is that fair to say, or is it something different?
Yeah, and we always clarify everything we say with device dependent, device design dependent. But yeah, if you be in the industry with what we call traditional conformal coatings like silicones and acrylic, urethanes, and even O-rings and enclosures. But the really great thing about chemical vapor deposition and sterylene coatings and plasma enhanced chemical vapor deposition coatings is that they really ingrain and embed themselves into what you're coating. And if just say you have a device that you drop in water and water gets into the device and it doesn't have a way to get actually bend the device and have the water drip out, and then you still okay. But with our coating, you don't have to worry about the moisture getting trapped inside that device and then causing long-term corrosion.
Okay.
That's where there's a real advantage. And the other advantage of coatings are that we will typically make coatings that are under 30 microns thick, where some of the other more traditional coatings you may, to get the same kind of protection, you might have to go to 75, 150 microns. So if you have a big device, and I'll use just an example, outdoor LED display, you're trying to coat the electronics and protect them from corrosion. Do that size of the billboard with a very heavy coating, it's going to weigh that product down. But because our coating is so much more lightweight, thinner, do the same work and can provide without all that thing.
Okay. And you brought a slideshow today, so I'm going to help you drive that. And let me just take a moment to pull that up. So let's go through the slideshow. And
sure. I'm going to have you jump to the next slide. Thank you.
There we go. Yep.
The way we go about with our business model, like with a traditional conformal coating like a silicone or acrylic, a lot of times customers will they'll buy that material and they'll buy the machine that will spray the coating onto the device. The way we handle applications is we provide a turnkey service solution to our customer. So we will work with the customer from the beginning and say, okay, from a technical perspective, the concept of designing your product, what kind of protection do you want? What kind of new product introduction do you want? How would we operate within your manufacturing facility if that's like we really evaluate everything that the customer wants and needs, and then we design the process and the coding around their needs and their budget, and then we work with them in production. Actually, we can provide a service a couple of ways into a customer facility and set up a and factory model where we put our equipment and our people in there, and we will take care of. They hand us the part that needs to be coded, and we will do all the pre-processing work, the coding work, post-processing work, and then hand it back to the customer, and then they'll put it into their assembled device, and then they'll send it out. And the reason why, and we also do coding as a service model. So send us, we can coat them we can pre-process, coat, and post-process device, and then ship it back to them. And we have all centers of excellence. We have them in China, Vietnam, and the U.S. So we really work with the customer where they're getting this.
So if they wanted to select the option of you coming in and actually fitting into their facility and fitting into their process operations, what sort of things do they need to take in consideration for that to actually happen? Like how much space do they need? If they don't have the space, is there ways to work around that to maybe, retrofit an area? And bring people in, and then you mentioned something too, that you bring your own people in. Is there any kind of training offering that HZO provides, so in case they want to maybe train one of their own to take over that? Can you tell us a little bit more about that whole process?
Sure, those are a lot of great questions, so I appreciate asking them. So we work with the customer from the beginning. We find out what their their daily processing or weekly processing requirements are. So some
Okay.
customers may only want 1,000 boards per day. Some customers may want 30,000 boards per day. And we have to, that's why we have to ask a lot of questions and do a lot of. We'll find out what their needs are, and then we'll design the equipment layout based on what their production requirements are, and then we can tell them how much space they would need within their facility. So it's really going to depend on how many parts they want at a time, how many shifts they run in a day. Because with chemical vapor deposition, actual coating processes, depending on what material you're using, can take anywhere from 10 hours to. So we have to really figure out what the customer wants and tell them how we would go about doing it. And
Okay.
what our area of expertise is the coating process itself, and production process. So when you have a board, there's a lot of things going on a circuit. And
Right.
in the way chemical vapor deposition works, it's amazing because it'll coat everything that you want coated. But the bad thing is it'll coat everything that you don't want coated. So we will take, if you have parts surrounding that neck coated, we will do a mask, cover those up, then we'll put them in the chamber, coat them, and then we take them out and we remove the masking. So that's where we have it's not that we couldn't do that. It's that we can do this at volumes of, we have customers that want 300,000 units per day done.
Wow.
We know how to do it, but we have different ways to do it. So we can manually do that, or we have automated equipment, robotic equipment that will actually put the masking on, take them off. And we have very high yield. Our yield rates on our production process are over 99%. So think about if you have 300,000 pieces in a day or 100,000 pieces in a day that you want coated, you're going to get very high yield, and that's part of the job.
That's great. Should we go to the next slide then?
Sorry about that.
No, you're fine. I also wanted to ask another question too. So it's chemical vapor deposition, and the word that's sticking out to me is vapor. So is there any extra safety precautions that they need to consider integrating? So if you're coming in and retrofitting a space in their facility to include, some of these machines that you're using and maybe the robotics and stuff, are these chemicals toxic or dangerous where they need to have it in an enclosed space? Do they need special gear? Like what are some of the safety considerations they need to take in?
Well, people always have to wear gloves and safety glasses. We always recommend that. But in the process itself, and I'll explain a little bit so this diagram makes a little bit more sense. But there's essentially a cool trap at the end of the process. So when we're evacuating the chambers, the vapor will go into the cold trap, and then it'll solidify.
Okay.
Then all you have to do is take that the solid parylene out, and then you just remove that properly. So and again, I'll walk through the process. I do want to point out that with our coatings, so VOC, volatile organic compounds, there's no salt, there's no catalyst. It's very safe process for a long time, and there's no. The other point on the last level there, so when the device really comes out of the chamber, we have to do masking, but then we can turn that back to the customer they can put it in their device and it can be on its way. There are some coatings that have times, and it may be a couple, could be hours. We'll be worried about the treatment. And then we do have Caroline, and how it's free is a big deal. Electronic devices are lasting longer and longer. There's an initiative in Europe where they're going to be pushing repairable, so they don't have to go and get traded. If you're using a halogen-free coating, it's really being disposed of. You're not releasing any toxins. So I hope I answered those questions. But what I wanted to try to do in this diagram is show you that the way paper deposition process works and the way we create our perylene coatings is that we start the process with a solid powder, and we call that powder a dimer, and then we actually sublimate the powder itself and convert it to gas without having to go into that. We straight from a powder into the gas. Then after we sublimate the powder, we're going to put through what we call a paralysis chamber or furnace. So in that paralysis chamber, that's where the material gets heated up to anywhere from 500 degrees C. And that paralysis chamber, that's where we actually put the monomer molecule itself, it's monomer vapor. And that monomer vapor actually on into the chamber, and that's both the active chamber. So there's flow and then we'll I'm sorry.
Lisa, I'm sorry to interrupt you. They're noticing a connection issue on their end. Is there a way you can check your Wi-Fi connection? I know you said that you can only use Wi-Fi. It's one of the downfalls of being live on video recordings. Sometimes you run into technical difficulties that you don't have control over. And we appreciate everyone's patience that's watching and letting us know when there's problems.
I'm hoping that is better. Can everybody hear me?
I can hear you now. I'm wondering, do you have earbuds or something with you? Maybe that might help a little bit.
I'm going to apologize.
No, that's okay.
I'm unprepared today. So.
That's okay. No worries.
I actually had these issues, and I came into the office because I don't have great internet connection where I live. So
I gotcha.
Yeah, so we'll try to plow through it, and if anybody misses anything, I'm happy to send these slides out, and I'm happy to answer any questions and pass the contact information out too. So
yeah, let's definitely do that. So we'll continue the presentation, and then if there's any misinformation, we'll include Lisa's either LinkedIn profile or email, whichever one you're more comfortable with. I can put that on a banner at the end, and then you guys can reach out to her personally, or you can also reach out to me. I'll include my information at the end too, so just let me know. But thank you again, and again, sorry for that. That's one of the downfalls about being live. Sometimes you have technical difficulties you can't control or predict, so sorry about that, Lisa. I didn't mean to interrupt you.
No worries. I apologize for my end. So once we evacuate the chamber, that's when we can take the devices out. And then, like I said, if we have to do any demasking, we'll demask, and then we pass that circuit board back, and they can put it in. So what's interesting about, PVD equipment can come in a wide variety of sizes, very small coaters all the way up to our chambers are the biggest in the industry. So we can put, when it comes to small boards, we put 10, 11,000 boards in the chamber. So we've got large capacity and high yield in our chamber, in the coating chamber. So I'm going to have you jump to the final slide in this presentation.
Is that it?
Yeah. So really, this is what we do is we provide next generation. We use CVD process to create parylene coatings, and we can. Parylene coatings are really the gold standard for corrosion protection. So there's some of the more like consumer products. If you read in the fine print, they'll have what they call ingress protection ratings, and you can use our parylene coatings to get that protection level. Then we also have plasma enhanced CVD that is a lower cost coating that has a lot of versatility. And I talked about our capacity, availability, and our build rate. But we do have we can set up really anywhere in the world, but we do have coating centers in China, Vietnam, the United States, and we have a really impressive. That's kind of my spiel on CVD. And before we try to show the video, did you have any other questions? Meaghan, I think we had a couple things.
Yeah, so with Mavens of Manufacturing, one of the goals that I have is to, let people know what sort of career opportunities there are out there and really try to inspire younger generations to think about the manufacturing sector as a career pathway, because several conversations that I've had with different women in the sector, they either fell into manufacturing by accident or they grew up in a really strong manufacturing family. Or, they had someone in manufacturing and it wasn't really something that excited them. So for me personally, my father has been in manufacturing his entire life, and we really didn't make a connection with that until maybe 3 or 4 years ago, where we really started talking about the sector more with each other and some of the trends. And he does some consulting on the side now after his retirement, but he's worked with a lot of different companies like Fisher Price, Fairbanks Moores, ABC Rail, Regal Cutting Tools. So he's seen everything from CNC machining, lathing, milling, just a bunch of different areas he's been in. And I really fell into this sector by accident in 2008 as a writer. My background is technical writing, so I was looking forward to writing manuals my whole entire life, and then got an editor position and was able to interview a variety of different people about the products that they were making and how they design them, how they produce them, and I really got passionate about it. And now, being a mom of 3 with a daughter who's about to graduate next year, none of her friends are really talking about manufacturing. Mm-hmm. They're all talking about healthcare, education, or social services. None of them are really thinking about engineering or manufacturing. And with HCO, you mentioned robotics, which is a really interesting part of the sector. You're working with chemicals, so I'm assuming you need some sort of chemical engineering background. So I just wanted to see how you got involved with manufacturing. Was it something that you were really excited about during your younger days, or was it something that you accidentally fell into? How did you get involved within manufacturing?
Back when I was in high school, I took my freshman year a class where it was a rotational class where you took an automotive class, a woodworking class, a machining class, different classes, drafting, and try out different technical. And then I really fell in love with that. And back in the old days, we used to hand draft. There's no AutoCAD. We actually did all this work on a drafting. And I kept taking classes in drafting. And but I was also taking. And I talked to my father about becoming a. And he said, "Well, why don't you think about going to engineering school?" And I was like, "Oh yeah, give it a try." So I went to engineering school, and, really enjoyed it. And then when I got out, my first job out of college was an applications engineering position. And they eventually transitioned me over into a product management position because I worked really well with customers. So my position, I kind of fell into all of this. I'm really glad I did, but it really started with getting that exposure to, and I'm a big fan of promoting STEM careers with men and women at a young age. And I think mentoring people in high school is a good way to people. And there's nothing wrong with becoming a nurse, or there's a lot of great career paths. But I think manufacturing, I've always worked with manufacturers, and I've always worked with engineers and scientists. I just think it's a really interesting career path. And the neat thing about manufacturing is that you walk out onto a production line in a lot of cases and see what's going on. And it's just really interesting. And if you're someone who wants to get fingers involved in stuff, and so it's a great career. But I also want to point out that in manufacturing, it's not just, different areas you can go in, because manufacturing companies need engineers, they need technicians, but they also need purchasing people and sales and marketing and product management people. I mean, it takes a village to run a manufacturing company. So there's so much diversity to it that that's what I find exciting every day, and that's what gets me up and going. I have an hour commute each way to work. I wouldn't do this if I didn't enjoy what I was doing.
That's the same with me. I work with, so I have my own freelance thing on the side where I do technical writing and different content creation for a variety of different manufacturing companies. But my full time gig, I work at a photochemical etching company, which I didn't even know was a process. I was used to hearing about the traditional ones where it's like laser cutting or additive manufacturing, which is not so traditional. It's a lot newer, but and then you have your CNC machining, and then they're like, yeah, we photochemical etch parts. And I'm like, what does that even mean? Like, what are you talking about? And it's a really cool process, but not too many people are familiar with it unless they're using it. So I like being able to tell that story of theirs because it's used in so many different components that we use every single day. And it's just, it's in Chicago, which is like an hour away from where I live, but I love going to work and helping out, telling their story. So I feel like with younger generations too, providing that value is extremely important. Like they want to feel like they're a part of something bigger that helps everyone live their lives a lot easier. So I was wondering, from your personal perspective, as a woman in manufacturing, what are your thoughts on how, as a nation, we can start recruiting younger generations so that they actually come into the sector but also stay? Because I have talked to some companies where they're producing products at such a high pace level, and I think some younger generations will come into a high paced environment expecting something completely else, something different, and then when they're faced with that, high paced, high stress level, they kind of freak out a little bit because they don't. It could be from a variety of reasons, like they don't want to fail or they don't want to look like they don't know what they're doing. So, in your opinion, what are some of the ways that we can bring those younger generations in and get them to actually stay when they come in?
I really believe it comes down to mentoring at an early age, and I think manufacturers and leaders need to even get into middle school and start talking to students there and in high school and just showing them the opportunities and telling them about it, and getting people, getting students interested, getting them to ask questions and show them. I need to be brutally honest, like pros and cons, but you have to make it fun and interesting too. I mean, for my personality, I like to be busy, and so manufacturing is a good for me. And I like to be pretty hands-on, so I like to dig under the hood. So it works for me. But we really have to get to these students, and we have to be really consistent in our mentoring. It's not I'll have a couple questions and then no, it's continuous mentoring and getting them, bringing them to your factory and showing them what's taking them on tours and showing them what you're doing and get them excited and motivated. Like that back at an age all the way through high school and into college, offering internships and co-ops. I think those are really the best ways to educate and recruit, and just showing them that there's so much that can be done, that many different communities. And the other reality is that I make a good living. I've made a good living, and I supported myself in what I've been doing. And especially as a female, I was always encouraged by my parents. Boys, they got up with girls. You have to learn to support yourself, take care of yourself. So, and what I've done since the beginning, and it's not make it intimidating. To me, there's no such thing as a stupid question. I used to, when I was coming to meetings early in my, this is a dumb question. A lot of the males I worked with, there really is. So encourage people to be curious. Have them ask as many questions as they want and put the time in.
Right, I agree with all of that. You hit on so many good points, and a lot of the conversations that I'm having with different women in the industry, I've heard that some people are afraid to enter the industry or the sector because, they might be a single mom or they might just have kids and, there's not that flex time. But then I talked to a student last week who is going through a CNC machining program, and she's a mom and she has a daughter, and all of those great characteristics that she's instilling in her daughter, just to show her that hard work does pay off. And she's already got like 3 or 4 job offers, and she's not even done with school yet, and she's really taken on a leadership role with the entire of their class. Her teacher basically said that she's like the mom of the class, and she takes everyone under her wing, and I think that's amazing. But I also think hitting that curiosity as well too is very important, and manufacturers need to start getting those stories that are making a huge difference, where we might not think, hey, this had something to do with chemical engineering, or this had something to do with CNC machining. A part that we make is actually in this big thing that's going to Mars, or this thing that's allowing robotic surgeries and saving lives, or components that are going in the ventilators that were for the pandemic. I think manufacturers need to start archiving those stories so that they can share them when students are coming in, or if they're bringing their parents in with them too, to actually provide that connection to the outside world and how it's making a difference. I talked to a woman, she's going to be a guest coming up in the future, and they make components that were in the cameras that helped catch the responsible individuals for the Boston Marathon bombing. Their components were in that camera, and like, who would have thought, that's a manufactured part, and it helped solve a big crime that happened in our nation. So it's really, really cool to like hear those stories, and I think kids get excited about that and they want to be a part of it when they know that it's something. I mean, we have parts that are putting people on the moon, and then we're getting close to getting on the Mars. Like, we have something on the Mars already, but they're already talking about, okay, how can we put people on Mars? And it's just really exciting. It's all that problem solving, and I just get so passionate about it. I really hope like the stories that we're sharing here today attract those younger generations, and we can start closing that skills gap in that gender gap. But you have a video that you wanted to share as well too. So I just want everybody out there that's watching, the sound is not coming through. We needed an MP4 player, but that's okay. Lisa's gonna walk us through it, and it's still an amazing video. So here we go.
Yeah, this does a much better job than I do of explaining. This is one of our over in affairs. when I talked about those higher speed productions where you're today.
So you have the circuit boards that are found in all of our electronics. That's what I was talking about if you dip something in water.
We do that demo all the time, by the way. We throw computers all the time. And this is where we spend a lot of time with customers to find out what needs are. So you're going to see in this equipment here, automation does the process. And that's one of the coating machines. So that where it says
Okay.
8,000, yeah, that's a chamber. So you have rack of circuit boards that are getting put into chambers and getting.
So in those chambers, how many pieces can you fit at once?
It all depends on what the size of the part is. So in smaller circuit boards, you can get thousands of those into a chamber. The chamber is a 1 meter cube chamber size.
Okay.
And again, chemical deposition, thermal coating, all the way around. And if you have a part, where that coating all the way around and underneath. This is the mapping and that's the high speed equipment we're using to actually load for the equipment. And then this is where they're showing putting again the rack into the, and we monitor machines. They're all over the world, and we have a person who his job is to monitor all of that globally. It's in Utah, and if it's a problem with equipment in China, he knows about notification that hey, maybe we got to drop, or we have eyes everywhere watching.
That's all robotics and automation right there. This is amazing. There's so many different career pathways involved in this entire process. It's amazing.
And we have to manually inspect the circuit boards to make sure they've been processed correctly, but we also have automation equipment that will do that optical inspection.
This is great.
And sorry.
Oh, go ahead.
I was going to say, this industry is only going to get bigger, like emerging applications. I'll give you an idea. Back in the 70s, on a car, automobile, you probably had maybe 1 boards at best in the car. And now, as we're looking towards autonomous driving cars, you're going to have probably well over 100.
That is crazy.
And
I'm
sorry.
Yeah. It's amazing because there's so many components out there that are like just a pin drop size, and the stuff that's included on it to make something work blows my mind. It's just amazing. But yeah, so anybody that's watching out there, I mean, you saw automation, you saw robotics, you saw inspection, you saw CNC, well, not CNC, but you saw controls and computer programming, all of that. And then in order to get into facilities, you need your people that are good with people skills. So all the career pathways demonstrated in one video. I love it. Well, Lisa, I want to thank you so much for taking time out of your day today. And I do apologize to everyone out there if there was continued technical difficulties. I'm going to put Lisa's information on the bottom of the screen again. Again, she's Lisa, Director of Product Management at hco.com. She's also on LinkedIn if you want to follow her on LinkedIn. Lisa, do you want to provide your email address, or do you want them to just...
Sure. No, my email address is really easy. It's lrizzo@.
So for all of you, if you didn't hear that, it's lrizzo@hzo.com. Think of Rizzo from Greece. That's how I remembered it. And yeah, so thank you so much, Lisa, for everyone that joined us this morning. I appreciate it. And we have another great episode next week for Mavens of Manufacturing. I hope you all have a great and wonderful weekend, and we'll see you again next week. Have a great weekend. Bye, everyone. This episode has been sponsored by IAEA Marketing. Sales just don't happen. We believe everything starts with you, yourself, your personal brand. People buy from people they know, like, and trust. IAEA Marketing is on a mission to help entrepreneurs earn the attention of their dream clients without using paid ads, automation, or creating a webinar. Contact IAEA Marketing to schedule a free 30-minute strategy session at iaeamarketingnetwork@gmail.com. That's AYALA marketingnetwork@gmail.com.